is this is something called p-plane. It's built into MATLAB, and this is. Oh, you asked me a question about like, is this like direction fields? Yeah. That was the question I'm thinking about. So this this system of autonomous ODEs corresponds to, you could think these equations right here would be the equations for the integral curve if I had the vector field f of xy equal to x plus y, comma x minus y, right? If I want this to be equal to like dr dt, which would be dx dt, dy dt, right? So in other words, this vector field matches up with the tangent vector field to a curve. These equations are the equations you have to solve for the integral curves of the vector field. And so what I'm showing is by canceling out the dt, I can solve using the method of exact equations for the integral curves as just a Cartesian equation. But there are other things you can do. For something like integral curves, you can also directly visualize the vector field and see the integral curves using something called p-plane. Here's how you do it. This is a built-in function in MATLAB, I think. So like x plus y, and y prime is, what was it? X minus y is what I did. And let me be fair, I'll do like a 4-4 window, something like that. The way this works is you graph, and so these arrows, that's actually the vector field, the picture of the vector field x plus y, x minus y. Now the difference between this and the isocline method that you may have seen in like Calc 2, or Calc 1 even, I forget, is with the isoclines there's no direction arrow, right? It's just like dy dx. It's the slope of the isocline is dy dx. So isocline is what you would make for something like the dy dx equals to f of xy. That would be ideal for making the isocline plot for. You just draw a graph, and there's like lots of whatever. And these dashes represent the slope of dy dx at the given points. In contrast, this has a sense of direction, right? Because there's differences. There's arrows here, whereas the isocline plot has no arrows. But the awesome thing about p-plane is you can click and see actually what these solutions look like. So apparently the level curves of this function, excuse me, the integral curves of that vector field follow hyperbolas, as you can see, right? And there's something special about the origin, right? Right. Now, so you can directly plot vector field, you can directly plot the solutions to this system of differential equations, x and y as functions of time. But there are other things, like there's also this so-called other tool I like to look at sometimes is the D field. So here, this is not, it's annoying. The t is what we would usually think of as being x, or vice versa. Let me throw it in there. Yeah, t is, x is y, and it's annoying. X is y, and t is x. See what I'm saying? So we would look at something like dy dx equals to f of xy, right? There's no time in this. So what I'm saying is he's got like x prime is equal to first order differential equation of the form x prime is equal to f of t comma x. So I mean, you see what I'm saying? This becomes dx dt is equal to f of t comma x. I mean, the roles, don't be distracted by the names have been changed to protect the innocent or whatever, you know. And so I have, in here, I have already put the differential equation we started with today, which was what? Negative x over y, right? Let me make it symmetrical here. graph my phase plane. And as you can see, the not parametric form, it's inferior. It's just better. This viewpoint is just better. You see the stupid software, it chokes. Where's it choking? It's choking because we're looking essentially at dx dt equals to minus, what is it, t over x, right? And so when x is 0, it's like, I don't know what to do. It's just sad. Sad. So sad. How do you convert? Oh man, that stupid t. Fine. Let me, if you don't mind, dy dx. So annoying. What would the corresponding autonomous system be for this? How would you take this differential equation in x and y, convert it to parametric differential equations for x and y? Yeah, like just divide by dt, right? So it's, I mean, here it is, dy dt over dx dt is equal to minus x over y. And so it seems like maybe that this autonomous system should correspond to our first example. Does it? Now I will go back to p-plane and plot it there, because p-plane is the thing to plot autonomous systems. What did we say? X prime was what? Minus y? What? Y prime was what? X? Other way around? So y and minus x. But you could see that you could go either way, right? See it? Circles. No problem between, you know, the beauty of the parametric viewpoint is it's no respecter of Cartesian coordinates. X and y are the same, right? There's no distinction in the parametric viewpoint. That's why it's better for circles, because circles also have this feature, right? What would have, and you see that these circles are what? Yeah, clockwise, right? If I had made the sign error we talked about, quote unquote sign error, what would happen? Other way, counterclockwise. Yep.
So you said what we got for G over there wasn't an exact solution because it wasn't in time.
Oh, this? Well, this is not a differential equation in x and y. So I can't.
But you said something about
All the way over there at the end.
Oh, over here. No, this actually, this equation right here, let me box it. This guy right here is in fact, yes, an exact equation. I don't think that has to happen, generally speaking. There are lots of things I could put here that wouldn't be exact. For example, I doubt that this is an exact one. And I really don't want to solve the so-called, the corresponding xy equation, because whatever it is, it ain't pretty. The beautiful thing about p-plane is even though I just made up this differential equation, x prime is equal to minus y plus xy, you know, I just made that up. I can already see solutions to it, even though I don't have formulas for them. It's a numerical method, which is super interesting, super useful for you guys as engineers, because if you have some system, you model it, you get a differential equation. Even if you can't solve it, you can still shove it into something like this and analyze what's going to happen, which is useful to know about. Anyway, I just wanted to make some connections with differential equations for today. Now that I got that out of my system, tomorrow I welcome your homework questions. And if you don't have any questions, I'm just going to go to the book and start working them, ka-chunk, ka-chunk, ka-chunk. Yeah, you can hit it. Thanks.